There are two aims to this video. We're going to firstly look at the comparison of compound interest versus simple interest, and the other thing is to be able to do calculations involving involving compound interest, I should say. Now, I'm assuming you already know about simple interest and how to calculate it from your previous study, so make sure you know that first before you even try to watch this video. Now, interest, remember, is a fee for the use of money. So it's a fee paid as a percentage. So it's a percentage fee for the use of money. Okay, whoops, for the use of money. It's a bit untidy. So that's a bit of background. You should know that. If you invest the money, the bank's using your money and they pay you some interest. It may not be much, but they'll pay you some interest for the use of your money because they'll use it. It won't just sit in a safe, they'll use it for various projects. It's always going to be your money, and because they're using it, they'll give you a percentage fee called interest. And if you borrow money, you will pay interest because you're using the lending institution's money. So you might be basically borrowing from a bank and you'll pay interest. So let's start for scenario, and we'll keep it easy. And basically, let's say you've got $1,000 and basically you are borrowing $1,000 and it's at 8% interest per annum meaning per year, and let's say the term is over 3 years. So we're going to look at how the interest you owe increases as time goes by, comparing simple and compound together. So now we've got simple interest formula. You can see in green on the left. I equals PRT over 100. You might have seen something like that. There are a few little variations of that formula, but that's basically it. So P is the principal, R is the rate as a percentage, therefore it is over 100 as you can see there, and T is the time in years because this interest rate is set up per annum. To get the amount, the accumulated amount that you owe, you have to add the amount you borrowed, the principal, plus the interest, which is calculated by that formula there. Okay, so that's what you should already know before you do this. And basically we're going to show how compound interest works, and we're going to derive the formula through comparing it to simple and making one adjustment to the simple to get the compound interest, as you will see. So for year one, if we look at the first year, you've borrowed $1,000. Now I'm going to deliberately sidestep the formula for a minute. Just going to go on a year-by-year basis. Year one, you basically have $1,000. So the amount you have there is $1,000, which is the principal there, plus the interest. Now in 1 year, we've got 1,000 times 8 over 100, because that's your 8%. You could call it 0.08 if you like, times 1 year. So we've got 1,000 that you started with plus $80 of interest. I'm just highlighting that. And basically then we've got $1,080 owed. Alright, after year one. With compound interest, the first time period is the same. So we have exactly the same thing. We have $1,000 plus that, and we're exactly the same. So no difference first year around, at the end of the first year at least. Okay. With with simple interest, I should say, it does the same thing each year. It's a flat rate. You should remember that from your previous work. So it's another year's worth of interest, which is still 8% of the $1,000, and you'll get the same calculation, and bang, we'll get 1,080. So 1,000 plus 80 is $1,080. Okay, so it goes up in a flat way. So just highlighting that, and that's not mind-numbingly shocking. All right, it's not anything, and if I did third year, it'll be the same calculation again. But hold your horses. What about if we reinvested the interest into the next principal, and we have 1,080 there as the new principal. This is what happens. You see the interest here, this gets put aside each time and it piles up, and it's not paid to you until the end, so it sits there, and when we do it for year 3 it'll sit there too, so it'll be 3 lots of 80. Okay, but with this one over here we have 1,080 plus 8% of the 1,080, so it's 1,080 times, that's a times, for another year, that equals 1,166.40. And oh my gosh, I've just spotted an error on the left hand side. With the simple interest, that should have been, whoa, we've got a little error. I don't hide from my errors. So that was what we had at the end of the first year. That should be the next bit of principal, shouldn't it? Okay, we now have 1,080 there. I'm just putting that in just so you can see it in brown there. But the interest is still based on the original amount there. Okay, so let me fix that up. So we have 1,080 plus 80, and I need to fix that up now. So that will be a little bit different. That'll be 1,160, because 80 and 80 is 160. Okay, so apologies there. It's alright, we all make errors. So we have a very slight advantage there when we look at the 2 at the end of the second year to compound. Okay, so what's the big difference there? The big difference is that we base the principal on the new principal here, whereas simple keeps on basing on the original principal. So this actually gets reinvested, okay, and loosely you could describe it as snowballing. It builds on itself, and if it keeps going this way, it will actually be exponential because it's a multiplier. Okay, so we've got $1,240. Another of those 80s is being put in there, and it'll all get paid at the end. So at the end, we've got 3 lots of 80 above what we started with. Remember, we started with $1,000, and with simple, we've had 3 lots of 80 added on, which is 1,000 plus 240, and there we go. It just goes up by 80. So that's actually a linear function. It goes up by the same amount. Okay, it's got a gradient if you plotted it. We're going to have a look at the plot in just a minute. So that's that one, but with compound, it's a little bit different. So let me get my line and just so we don't get the two sides mixed up there. All right, so let's go back and look at the third year, year 3 for this. So we've got what 1160.64, 1166.4. Let me get that right. And we've got our basically our new amount. And not only do you get to start from a higher accumulated amount, the thing that the interest is based on is higher as well. So double whammy. We've got that calculation there, which is following the same pattern as before. And look at that. So we've got interest is going up each year. All right, look at the yellow bit. As we go, the interest is going up. All right, it was the same as on the left hand side. It was 1,000, then it became 1,080, and then it became on 1164. So the interest was 80, then 86.40, and now what's it going to be? Let's calculate that. The interest is going to be $93.31. Okay, so that's gone up. Look at that. So it was 80, and then 86.40, and then 93.31, and we get to add that on to a larger principal for that period, and we're starting to get away now. Once we add these together, starting to get away with the corresponding amount from simple interest. Let's have a look at how it goes. So we've got 125,971 there. So the interest goes up each year, and of course the accumulated amount goes up, and it's not going up in a linear fashion, it's going up in an exponential fashion. It builds on itself. And so this took a long time to do. You know, we're 7.5, 8 minutes into this, and we just did 3 years. So of course there's formulas. Okay, so the formula is, you know, as I said initially, it's P plus PRT over 100, which is actually a linear function. That's not important for this video, but this one here, we actually have a formula. We could summarize that, and to save time, basically we have 1 over, sorry, P outside of 1 plus R over 100 raised to the power T is basically your compound interest formula in simple situations. Okay, so P is the principal, R is the rate as a percentage, remember that rate, if that rate's given as a percentage, you divide it by 100, and T is the number of years or the number of time periods. Okay, so that's for simple situations. That's for per annum. Okay, that's compounding once a year. If you compound more than once a year, that's more difficult. So what we've got in the cases where it's compounding more than once per year, we have to use this. Now it introduces a new symbol, and you can see a little n there. Now n is the number of compounding periods, so n equals the number of compounding periods per year, and so if it's monthly, n equals 12. If it's quarterly, that's 4 times a year, so n equals 4. Okay, if it's weekly, and it would equal to 32. So, you know, there's all different ones. Quarterly and monthly are two of the most commons. If it's yearly, that n is equal to 1, and we revert back to the top formula there. Before we do some calculations, okay, let's have a look at the graphs of simple versus compound for that example we just looked at there for this one. So we can see the red graph there is simple interest. Okay, so we had that $80 added on each time, and you can see that it gives the red graph, which basically accumulates the least amount. Now, if this is a loan, this is good news. You'd prefer simple, but if it's an investment, it doesn't perform as well as the other two lines. This one here is that annual one that we looked at, and so after 3 years, 1, 2, 3 years, you can see the two amounts. So we had 125,971. So 125,971. There it is, right there. So it's right. Okay, so we've basically can see that it pulls away. Okay, it pulls away. Can you see where my cursor is? What about this green one? That's if we compounded monthly. See how we've got our 12 for our n there. Look at that. So it does even better, not by the same gap, but look, the green outstrips. So if you compound more often, you'll owe more, or your investment will perform better, depending on the situation. Okay, so the more times it compounds, if everything else is set, the more it'll accumulate in terms of debt or investment, depending on what you're doing. So what I'm going to do is, that was a lot of setting out above. Basically, I'm going to just use these two formulas now to show the situation. Once again, we had P equals 1,000. Using the formula, this will be much quicker. R is 8% and T equals 3 years. So compound interest, A equals P outside of, this is, first thing we'll do it annual, so one compounding once per year. We'll try that. So that'll be the top formula there. So that's the green one. And we have 1 plus 8 over 100, which gives us that 0.8, and that's cubed. So we put then, remember, do your brackets first. So that'll actually be, sorry, I better sub in the P, which was 1,000. And 1.08 will go in here, and that's cubed. And we do our calculator work, and that comes out to 125,971 if you use a calculator. That's the same as what we had before, 125,971. Okay, what if we compounded, what if we had the same thing and compounded it monthly? So that's the yellow formula where n equals 12. Okay, so what effect will that have? And that'll match that top graph that we saw. Okay, when we looked at the graphs, we saw, so this one here doesn't outperform it too much early on, but as time goes by, there's a bigger difference, isn't there? Okay, so, and also you can see the linear shape of the red simple interest graph and the curvature showing the exponential shapes of this one and that one. Okay, so let's try it for compounding monthly, keeping everything else the same. So for monthly, n equals 12, so we would have A equals P outside of 1 plus 8 over, now it's n times 100, which would be 12 times 100. Raised to the 3 times 12. So that would be subbing in the 1,000 for the principal. 1 plus 8. 8, come on, 8. 8 over 1,200 to the 36. Okay, we get the calculator and do that. And you can break it into bits if you like. If you're scared about it not producing the right answer, we can chunk that a bit, and look at the difference it makes to that number inside. You think, oh, that won't that give a smaller value, but we're raising it to a much higher power, so it gives a bigger number, as you will see in just a sec. So everything that's been raised to the power comes to 1.270, so we have $1,270 and 2 cents, so don't forget the 2 cents, and that's more. Look, that was compared to 125,971 we got before. So 1259 versus 1270. Yep. So, and that corresponds to the graph 1270. So 1270 after 1, 2, 3 years. Yep, there it is, right there. See that? So 1270. And we can see the effect of compound interest.